All right, what up, folks? So we're going to be going over a topic called significant figures, and it's something that I have to admit, I'm just going to warn you, it's a total pain in the butt when you're learning it, but it ends up saving you so much time and effort and writing and confusion once you got it down. And here, I'll just give you a kind of a story to kind of give you kind of an idea. But actually, before that, instead of saying significant figures, and you'll hear this a lot, scientists are lazy, especially physicists and especially me. So instead of significant figures, I might just call them sig figs, or siggy figs, or maybe just figs out of laziness. But here's kind of my story that'll kind of outline why they're important. So let's say I'm going from my mom's house to my grandparents' house, and my mom's house is in like East County, San Diego, and my grandparents' house is way up in the Bay in Hayward, kind of East Bay area near Fremont. So I just poked in the two addresses into my phone, and I have 492 miles of distance between them. And it says from my mom's house, I would just take 5 all the way up. And it's telling me that it should take 7 hours and 25 minutes if I just don't stop once. But let's say, just for ease of making the numbers a little nicer, it takes me, instead of 7 hours and 25 minutes, 7 hours and 15 minutes. Because 15 minutes is a quarter of an hour. So I have the miles here, and I have the time, 7.25. Now wait, I said it was 7 hours and 15 minutes, but 15 minutes is a quarter of an hour, right? So I have the distance, and I'm dividing it by the time it will take me. Well, distance divided by time, wouldn't that be like miles over hours? Well, this should give me miles per hour, right? So this is going to tell me how fast on average I'll be going if I don't stop once and I make it in this time frame. But do I really want to write down all of these ridiculous decimal places? The short answer is no. And sig figs is what tells you how many decimal places you get to write. How many of these things actually are significant? How many of these figures are significant? That's why it's called significant figures. And I'll tell you, as a shortcut heads up, the answer actually is, I would get here, 67.9 is the actual answer. I would round off of this first decimal place. And so this 6 would make the 8 become a 9. But now, how the heck do we figure that out? So let's look into that just a little bit more then, okay? And figure out, how do we actually do this sig figs thing, actually, in all honesty. So here's kind of the rules. The rules are down here. I like color coding. I would encourage you to color code. If you don't have, I don't know, colored pencils or anything like that, of course you don't have to. But I would say the most important rule is that you start the count from the first non-zero digit. Non-zero digit. That's what matters. That's the most important thing. Okay? And so, keeping that in mind, we're then going to go over, I'm going to grab blue. Now, if the decimal point is present, that means if there is a decimal place, you're going to count from the Pacific Ocean side. Oops. So you're going to count from the Pacific Ocean side. Well, the Pacific Ocean, this is why there's this stupid map here. So Pacific Ocean, well, that's this side. That's us. That's the West Coast, right? So there we are. Now, if there is no decimal, if the decimal is absent, you're going to start the count from the Atlantic Ocean side. So you're going to start from this side. So, as silly as it seems, I like to imagine that every time I'm figuring out significant figures, I'm figuring it's like a plane. Is the plane flying in this way, or is the plane flying in that way? And that's how I kind of will think about it and kind of reference it. So let's look at this a little bit more and do a couple examples just to see what the heck I'm even talking about here, okay? So first off, we have an example. Is there a decimal? Yeah, I see it. It's right here. So the decimal is present. Decimal, oh God, that handwriting is trash. Sorry about that. Decimal, that's better. not by much, but it's present. Okay, so again, start from the Pacific Ocean side if the decimal's present. Present, Pacific, they both have a P. Atlantic, absent, they both have an A. Okay, hopefully that's kind of triggering in your head a little bit, or starting to at least. So the decimal's present, so we're going to start coming in from the Pacific Ocean side. So I'm going to fly in this way. And what's the rule in red? Well, it says start the count from the first non-zero digits. So I'm flying in here. Well, that's a 0. That doesn't count. That's a 0. That doesn't count. That's a 0. That doesn't count. But here's 1, 2, 3, 4, because I started at the 3, the first non-zero digit. So what I would say here then is that there are 4 sig figs. 4 significant figures since the decimal is present. Okay, so really we started from the Pacific Ocean side. Now the one thing I want to mention here is zeros in the middle totally count, right? Like if this 0 was gone, this would be a different number. So that totally does matter. Zeros in the middle matter. Zeros in the middle matter. Okay, so let's keep going. The decimal's present. Oh, it even tells me how to do it. Great. So let's look at another example here. And first off, decimal, is it present or absent? Well, I don't see one. So obviously our decimal is absent. Okay, we have no decimal. Since it's absent, we start from the Atlantic Ocean side. We're going to fly in that away, is the whole idea. So we'll start in over here. And our rule in red still says from the first non-zero digit. So this 0 does not count. This 0 does not count. But this 1 counts. This 0 counts. This 0 counts. This 0 counts totally. So what I would say then is that there are 4 sig figs. Since the decimal is absent, and I'm going to kind of use my airplane analogy and flew in from the Atlantic side. And again, the middle zeros totally count. Okay, so these zeros didn't matter. These zeros didn't matter. The middle zeros absolutely do in fact matter. So that's it. That's all we kind of do with this. That's how this works with sig figs, as far as counting them, figuring them out from a number. Now, that's the basics of sig figs. But this isn't just reading numbers, right? I gave you this kind of example where I was dividing two numbers. Maybe we could be multiplying or adding or subtracting. And so there has to be a little bit more to it. So we're going to look actually really quick now at our kind of addition, subtraction, multiplication, division rules for significant figures, okay? So let's just kind of start in here. Let's keep going with the purple. So for addition or subtraction. Now this is kind of cool. There actually are like 15 different rules for significant figures, and they include like logarithms and exponents and all this. I'm just going to give you the bare bones. So there's 2 rules, and between these 2 rules, it'll work for all division, all addition, all subtraction, all multiplication. So for addition or subtraction, this one rule works for both. Okay, if you don't know it, you cannot show it. If you don't know it, you cannot show it. That's it. It's pretty easy, but now what the heck do I even mean by that? So let's just pick kind of some random numbers. Let's say that I have 0.00 356, and let's say I'm going to add that to 1.136. Okay. Is that a good example? Yeah, let's do that. Let's use these two. Okay. So I'm adding. I'm just going to add these two. Well, we have 6 and there's nothing here. Those are kind of implicit zeros, right? But I'm not giving you those. I have not told you those, and I'll explain why. We can assume they're zeros, but they're not written. It's a very subtle thing. But of course, we have a 6 here. We have a 5 here. Well, 3 and 6, that's 9. 3, 1, 1. Great. Okay, so what the heck does this rule mean? If you don't know it, you can't show it. So I'm going to do this little dash here so we kind of know kind of the same comparative numbers for each. So there's a 0 here that we're assuming when we add, and there's a 0 here that we're assuming when we add, but I do not guaranteed know that. Let's say maybe, I don't know, I was using a scale and I was weighing something, or I was measuring the length of something, and my ruler just isn't good enough. It's not good enough to tell me if these are 2s or 0s or 8s or who knows what. I literally don't know. For the sake of adding, yeah, we just assume they're zeros because it's unknown. But it might not be the case. It just means that whoever was getting these numbers didn't have enough information to give us what remains here. So I actually do not know what's here, but I do know there's a 5 and a 6 here. So if I don't know it, I can't show it. So what this means in the end then for us when it comes to adding, and it's the same with subtracting, since I don't know these two places really in this number, I don't know these in my final answer. I don't get to assume that. So really what this is going to do then is this 5 is actually going to make my 9 round up, right? So this is going to kind of affect that one actually. So I'll get 1.140 because I know 3 decimal places, and this 5 would make the 9 become a 10, and that would then leave a 0 here, and then we'd have a 1 here. So since I know 1, 2, 3 decimal places, I get to show 1, 2, 3 decimal places. That's the idea, okay? I hope that makes sense. So let's look at the one rule for multiplication and division. So for multiplication, and division. Okay, and now this one's always kind of weird to it's just weird to phrase, but the number with the least. The number with the least sig figs determines the number of sig figs in the answer. Now, here's kind of the way that I like to think of this one actually, is a chain is only as strong as the weakest link. Maybe that makes sense. Maybe that clicks. If it doesn't, forget I even said that. Okay, now here's what I mean though by a chain is only as strong as the weakest link. I have this chain that's made out of like hardened steel, okay? Except for the one link in the middle. One link in the middle is super rusted and janky and terrible. And so I hook it up and I'm gonna pull this trailer from a truck. And the trailer is 12,000 pounds. And every link except that rusted one can hold 20,000 pounds. Well, yeah, that should be fine then, right? Well, that weak link, let's say, can only carry 3,000 pounds. am I going to be able to pull the 12,000 pound trailer? No, that rusted one is going to bust. And then my chain is going to be worthless because it won't be able to carry it. So the whole chain, even though every single link except that one can carry 20,000 pounds, only that weak link that can carry 3 or 4, maybe we get lucky and it carries 4, still is not enough to pull the 12,000 pounds. So really that whole chain can only carry as much as the weak link. And so it's the same with these. So this is just like the division that I showed you earlier. Let's just do a multiplication one just to kind of show a different example. So let's say I'm doing like 3.57 times 4.6689. Okay, and let's say that equals whatever. Well, I know right here, decimals present, we come in from the Pacific side and we start at the first non-zero digit. That's what we started with, right? So that's kind of our rule. Decimals present, start from the Pacific side, start from the first non-zero digit. So I'll start here and I go 1, 2, 3, and it works the same with this. So here I have 3 figs. And this one, well, it's present again. We come in from the left and we start counting the first non-zero digit. So here's 1, 2, 3, 4, 5. So this one has 5 figs. 5 figs. But if I go and hit this into the calculator, actually, let's just clear this. Let's do 3.57 times 4.6689. Well, geez. Okay, we get all these digits. So 16.667973. Okay, so we have 16.667973. Well, if we look at this, we have a decimal. It's present. We come in this way. Here's 1, 2, 3, 4, 5, 6, 7, 8. Well, we have 8 figs here. 8. But we just said that my chain is only as strong as the weakest link, or the number with the least significant figures determines how many there are in the answer. So that means that my answer can only have 3. Okay, so well, how the heck would I round this? Well, we're going to have 16, but here would be my third. Well, we're going to look at the one after it to determine what it should really be. So in the end, it ends up being that this 6 right here makes this first one after the decimal become a 7. And so we get that our final answer is 16.7. And then we have our matching 3 figs. Hooray!